Hello, cosmic travelers. I'm Dr. Byte, and today I invite you to embark on an extraordinary journey through the history of the universe. Buckle up, because we're going from the very beginning of everything to the end of what we know. I can't promise it'll be a smooth ride. You might just have an existential crisis or two along the way. Every great journey has its thrills, so hold on tight. Before we dive in, I need to remind you that physics will be our best tour guide. Everything we discuss today will align with our current understanding of it, but remember, this knowledge could change in the next 20 years. Ready? Now that I've gotten the legal stuff out of the way, let's go. I wish you all good luck and a fantastic trip through the universe's history. Our adventure begins at the dawn of space and time itself, with the famous Big Bang, which occurred about 13.8 billion years ago. Today, this idea is supported by various observations, especially when we study the expansion of the universe. If everything is expanding in one direction, it's expected, according to the equations of physics, that at time t equals 0, everything was infinitely small. However, we still don't know exactly what triggered the Big Bang, and we can't say much about that initial period. This is because between t equals 0 and approximately t equals 10 carat minus 43 seconds, the laws of physics as we know them simply break down. During these initial moments, the four fundamental forces, gravity, electromagnetism, strong nuclear force, and weak nuclear force, were unified into a single force. Even today, we don't know how gravity separated from the others. Recognizing that, while we have a solid understanding of 99% of the universe's history and future, that 1% at the beginning remains a big question mark is a sign of humility. Understanding those 10 carat minus 43 seconds is one of the great goals of physicists around the world. After those initial moments, the universe began to expand and cool enough for the four forces to separate. During this inflation phase, which lasted only 0.001 seconds, the universe expanded dramatically, from the size of a single molecule to trillions of kilometers. This extremely rapid expansion left the universe homogeneous, which we can still observe today through cosmic background radiation. Now, let's talk about the formation of the first particles, quarks and leptons, along with their antiparticles. As the universe cooled, quarks began to combine, forming protons and neutrons. Something fascinating happened in this process. The symmetry between matter and antimatter was broken. For reasons still unknown, matter became predominant while antimatter virtually disappeared. During this annihilation, photons, fundamental to our understanding of the universe, were also formed. All of this happened within the first seconds of the universe's existence. To reflect on the magnitude of this occurrence, let's remember that a second is a very short period, but it's astounding how so much information and activity could take place in that time. After about 20 minutes from the Big Bang, the universe had cooled enough to allow the formation of the first elements in a process known as nucleosynthesis. Here, 75% hydrogen and 25% helium were formed, with traces of lithium. We know this because these proportions remain consistent in the stars we observe today. However, forming heavier elements is much more challenging and would take millions, even billions of years to develop in stars. After roughly 20 minutes, the universe had expanded and cooled enough for neutral atoms to form. However, for a time the universe remained a hot, ionized plasma. This was the beginning of the Dark Ages, where photons couldn't escape, and there was no source of light. If you could have observed the universe during this period, it would have appeared completely dark. About 380,000 years later, the universe cooled enough for the first neutral atoms to form, allowing photons to travel freely across great distances. Those photons we observe today as cosmic background radiation are like the universe's fingerprint. Now let's dive deeper. When those photons broke free, they traveled through the universe, but we weren't alone. We were surrounded by a vast cloud of gas and cosmic dust. The universe was like a bubbling soup of particles, but just like a perfect recipe, we needed time and the right conditions for the magic to happen. This soup would become the foundation for the first stars and galaxies. Thus, the cosmos began to sketch a pattern, with gravity pulling everything together to form the structures we know today. These first stars, known as population 3 stars, were enormous and hot, burning quickly and eventually exploding as supernovae. The explosions of these stars created heavier elements, such as carbon and oxygen, which are essential for life. Through the death of these stars, the first building blocks of life were scattered across the universe. This cycle of birth and stellar death is one of the most fascinating aspects of the cosmos. Everything gets recycled and nothing is truly lost. As those first stars shone brightly, they also contributed to the reionization of the universe. This process transformed the universe from a state of dark ages to a cosmos filled with light and color. Quasars, which are supermassive black holes, began to emerge at the centers of galaxies, illuminating the cosmos even further. Here, my friends, we witnessed the dance between light and darkness, an eternal cycle of creation and destruction. As galaxies grouped and merged, the structure of the universe began to solidify. Today, the Milky Way, our galaxy, houses billions of stars, each with its own story and destiny. Earth, in a quiet corner of our galaxy, became a home for incredible diversity of life, yet it is also a testament to the cosmic forces that shaped our world. Now, let's explore how planetary systems form. When stars like our Sun are born, they are surrounded by disks of gas and dust. These materials, through collisions and agglomeration, can give rise to planets, moons, and other celestial bodies. This planetary formation process is a remarkable example of how gravitational forces and available materials come together to create new worlds. So while Earth was forming, countless other planets were also emerging around neighboring stars. Over billions of years, Earth underwent drastic changes. The initial cooling allowed the crust to solidify, creating the first solid surfaces. Soon after, water began to accumulate, forming oceans and creating an environment conducive to life. The conditions on early Earth were chaotic, with active volcanoes and violent storms, but these natural forces were crucial for the development of the first unicellular life forms. As time went on, life evolved in extraordinary ways. The first photosynthetic cells began to produce oxygen, altering the atmosphere's composition. This oxygen increase was crucial for the development of multicellular organisms and, eventually, life as we know it. What once appeared to be a transforming planet became a vibrant home filled with biodiversity. Evolution didn't stop there. Life adapted to diverse environments, from the depths of the oceans to the tops of mountains. Through the process of natural selection, species went extinct while others diversified. This struggle for survival shaped the history of life on Earth and is reflected in the immense variety of species we see today. Every living being, from a simple bacterium to a majestic elephant, carries the history of millions of years of evolution. However, Earth's story is also marked by catastrophic events, such as the extinction of the dinosaurs. Approximately 66 million years ago, an asteroid collided with the planet, causing drastic climate changes and leading to the extinction of about 75% of species. This event, rather than being an end, became a new beginning, paving the way for mammals and, eventually, humans. Now, if we consider the scale of the universe, we can see that our existence is just a tiny fraction of its history. We are the result of billions of years of cosmic evolution, from the Big Bang to the formation of stars, planets, and finally life. This leads us to ponder, what will our future hold? What will happen to Earth, the Sun, and the galaxies in billions of years? The universe will continue to expand, and eventually, perhaps everything will cool down, leading to an uncertain future. As our understanding of the universe expands, we also encounter new questions. What else exists out there? What are the possibilities of life on other planets? And how does our presence in the universe fit into the cosmic story? Each answer brings with it new questions, and that's part of the beauty of scientific knowledge. And so, cosmic travelers, we conclude our journey through the history of the universe. The story of the cosmos is a testament to the power of physics, the complexity of life, and the beauty of the unknown. I hope you enjoyed our trip and that you're as amazed as I am. Remember, the pursuit of knowledge never ends. Until next time, and don't forget to hit that like button and subscribe to the channel for more scientific explorations.